And there have been delays on doing this, but now major pharmaceutical companies have teamed up with the Jennifer Doudna group you mentioned, which is Mammoth, and then Fong Zhang's group, which is Sherlock. And what it does, as you know, Laurie, because you've covered this well, is that it uses this simple technology known as CRISPR, but it's really just an RNA guide with an enzyme attached to it that says, okay, we can find any genetic sequence you want. I've been a bit disappointed. I thought they'd be out now. I think they'll be out by the summer. But in some ways, this will be a game changer because these will be platforms upon which other people can build great systems, such as detecting cancer cells or detecting, your gut microbiome. They can detect anything that has a genetic code, which means just about anything in our body. And so when that happens, it'll be like when the personal computer, when we first brought our first personal computer home, and suddenly microchips and networks were part of our life. I think having a home kit like this will be transformative to biology.
Dr. Osterholm is with us and has a question for you, Walter. Dr. Osterholm.
Yeah, well, thank you. Good morning, Walter, and we're all very excited to read this book, so thank you very much. This will be a very important part of our biological history here. As you know, and you have really thought a lot about this, over the course of the past several decades, we've seen science used for really good purposes, and we've seen science potentially used for nefarious purposes. I served for 7 years on the National Science Advisory Board for Biosecurity, which we looked at this kind of dual-use activity. And clearly, CRISPR has offered us so many wonderful, powerful aspects of science. Can you comment at all on how you see we're going to be using these tools in the future for good purposes, but how we minimize potential nefarious purpose use?
Well, thanks, Michael. It's good to see you again. For one thing, the Defense Department has already been funding in Jennifer Doudna's lab and other places, including at MIT, the notion of anti-CRISPR. So if a malevolent actor decides to use this technology, we know how to counter it. But I think the more important question that you're asking in some ways is how are we going to use it? How are normal, societies going to decide we should edit things? And I think, that's a
Evan, where are you?
book, as Jennifer Doudna and all the other people in the book, including philosophers and ethicists.
I want to show you something on my screen, how I can split my screen for you to watch something. Hold on a second. Are you still in class?
That happened last year with Victoria Gray, a patient down in Mississippi. It's happened in Europe with blood diseases. We're using it already on cancers, both in China and in Pennsylvania. We're using it already on a congenital eye blindness. These are all in clinical trials. The real question is what happens when you do what a Chinese scientist did at the end of 2018 and edit early stage embryos to make inheritable edits to make designer babies. And that doctor made a designer baby, so twins,